So, the last, when Gillian and I did our presentation in November, there was a few questions, and I couldn't answer them, so I researched the data. And essentially what we have is the Whitecourt Crater, just a quick review. Edmonton, where are we here? Edmonton, just to the northwest of Edmonton in Alberta. And the crater is just around in this area here. You can see it there somewhere? Those are the tracks from my locator on the airplane. But the crater is in there somewhere. And this is a LIDAR image of the crater. This is sort of like an aerial image. The crater's right there, actually. And the LIDAR is a way of eliminating the noise from the vegetation so you can actually see the ground. And this was a good beta test of the system, and they're, basically it's been proven that fact that we can see ground effects. Now the first question we had was actually from Paul, and he noticed a couple of pseudo-craters here. And we had great expectations of the new Paul Cloninger crater in Alberta. But I asked Dr. Hurd, and this is his quote, "What were the two craters in the upper right of the image?" Well, he says both of these potential craters were checked. The one closest to the actual crater is the remains of an old homestead, and the other one to the far northeast is also man-made from homesteading or forestry. So years and years ago, somebody was actually here trying to farm this. I'm not sure, they weren't very successful because the land wasn't very fertile. But another point in this LIDAR image is this creek here. And Dr. Hurd described it as ephemeral. Ephemeral? Is that how you pronounce it? Basically, it was a creek that was there before the crater, and it hasn't had too much water in it since. Which brings me to the second question that Simon asked. When I described the ejecta from the crater, you see all these sample points here is where the students were digging, and Simon asked, well, why is there ejecta in the creek? You think after 1,000 years it would have been eroded away. Well, again, his answer is, quote, "The ejecta does not appear to have been significantly eroded since the impact, although there is a little of interpretation there. I don't know how many auger holes my student did in the actual steam bed, but not many. However, it is an ephemeral transitory stream with water in it only in the wettest years in the spring. So suffice to say that there has been very little, if any, erosion of the ejecta since the impact." So that's the answer, Simon. And the third question, Brian, asked me what the exact meteorite was. And just a quick review, it's kind of fascinating actually. The meteorite that were found around the crater, actually two types. One with the regoliths, the erosion that happens with the transit through the atmosphere, and this shrapnel. And they were both identical meteorites, iron, and the exact type is a type 3AB iron meteoroid, which is low nickel metal areas, and it's actually right from the core of an asteroid. But the point here is that this shrapnel was actually blasted away from the bolide on impact. Part of it vaporized, part of it actually exploded, which you get this shrapnel. And then these parts here probably fell off on its transit through the atmosphere. So it's a very fascinating scientific hole in the ground that Dr. Hurd was researching. So that answered those questions, finally. Thank you. Now, this is a trip Gillian and I did last summer, actually on the way out to Whitecourt. We explored the northern Saskatchewan craters. And you can see Saskatchewan actually has been peppered by impacts over the years. Just a quick geology lesson. The pink area here is basically bedrock, and you'll see the types of craters in the bedrock. This is basically the deposits that created the prairies, basically the flat. interior plains is the geological term, and it's been basically post the major extinction of 250 million years ago is when it was deposited, this part. This here is a big hunk of sand called the Athabasca Formation, marine sediments which are believed to be Middle Devonian of age. And we're going to see some fascinating pictures of that in a second. So, first crater we'll talk about, I'm going to go by age, is Elbow, 395 million years old. 8 kilometers across, Devonian age, strata distributed, and it's basically before the Great Extinction this happened. So the extinction that I'm talking about is around 250 million years ago, the Permian Triassic, where about 99% of the life on this planet was extinguished. So that crater sort of got things started in Saskatchewan. That's where it was in the planet at that time. And there it is. You see it? This actually is Lake Diefenbaker. And the dam you see there is the Gardner Dam. It's the largest embankment dam in Canada. Kind of cool to see. But a closer look at the crater, and there it is, Lake Diefenbaker in the background. So essentially you can't see anything, but I just had to fly over it to say, yeah, I've seen Elbow Crater. It's 8 kilometers in diameter. It's buried. And to my knowledge, there isn't any carbon or oil or anything underneath the crater for some reason. It's the oldest one, so probably whatever was in there is long, long gone. So, to the next one is the Gow Lake crater, and that happened just after that major extinction. It is just after the, about 250 million years ago. It's 5 kilometers across. And the dinosaurs at this time were just evolving. They were evolving from this little lizard called an Archosaurus. And the mammals had just started their evolution trail as well. So the two species were in competition throughout the Mesozoic here, which is a cool story. So that's what the world looked like when Gow hit. And it is actually a fascinating little structure. It is the smallest known complex impact structure. It's complex in that it has a central peak. There are simple craters bigger than this on this planet. We can't, nobody's explained to me yet why this is a complex crater where others were not formed as complex. Just as a trivia, the fog in the background is smoke from the forest fires in British Columbia as we're heading west. We came through a lot of smoke in our trip. It was kind of cool. Well, not cool, kind of warm.
Chuck, do you know if that island in the middle is part of the uplift, or is that after the crater?
This is the central peak of the crater itself. And it is, the impact melt is basically the whole structure here is impact melt. This is a view from the east looking west towards British Columbia, and this is the view west looking east. And right on that point, there's this little lodge. It's kind of a neat little lodge. I'd like to research what's in there, because, Eric, that canoe trip across to the central peak would be kind of neat, wouldn't it?
Yeah, I was thinking about that.
Yeah, I was too. Have canoed, we'll travel. Yes, where are we here? Yeah, the cottage, it's the highest point is basically, it's all impact melt. So we could get a canoe full of rocks out of that one. So, age-wise, the next crater is the Viewfield crater in the south. Now this is buried under the soil of the prairies itself. It's a big one, 39 kilometers across, 115 million years ago. So at this point, the dinosaurs have about 50 million years before they meet their Waterloo. So it's coming close, so you think with all these impacts happening, they think, let's start a space program, see what we can do. But they're just out killing mammals. That's all they were doing. Where are we here? Blah, blah, we're on Prefield. Yeah, 2.5 kilometers across, not very big. And our continental drift is getting a little bit more recognizable, North America. And there it is. Now this one here has a lot of oil rigs in it. That was kind of cool to watch. Basically it's wall-to-wall oil rigs around here in southern Manitoba. And point zero of the impact is right there. Can't see the crater, it's buried, but there it is. Yeah, it's a trap for hydrocarbons, and essentially it's they've been pumping oil for a long time, and there still are. So the next one, age-wise, is the Carswell, way up by Lake Athabasca. 39 kilometers across, and it could be bigger. There are lots of studies going on, a lot of contradicting evidence saying it's bigger, it's smaller. 115 million years ago, the dinosaurs have about 50 million years left before the big day. And as you say, the continent's getting a little bit more recognizable, and that's where the impact happened. The Athabasca Basin itself, sandy deposits from the Devonian. Now the interior, if you look at, whoops, the crater itself right there, the interior geologically is pink as granite. It's pure granite. The yellow ring is the disturbed Athabasca Formation, and the outer ring is dolomite. It's a sedimentary carbonate rock. So that's the form of it. It's kind of very recognizable in all the forms. Now this is the whole Athabasca Basin. And looking at this image, whoops, this is the crater itself. All this is sand. It is really neat to see. And inside the crater is basically it's all like this. And this is the crater rim from the ground. So it is they say it's a ring of small hills about 50 meters high, and the diameter is about 30 kilometers to 40 kilometers, the hills. I really couldn't see it from the air. Ground zero is about here, and they say the ring of hills was around here somewhere, but from the air we couldn't really see it. And the smoke from the forest fires was just clearing a bit, so we did get a fairly good picture, but not as crystal clear as I wanted.
It's a bit smaller than Manicouagan.
Yes. Yes, the central island of Manicouagan is going to be about this size. And then the trench where Eric and I almost met our Waterloo is a little bit bigger than that. But that was a story, wasn't it? So, and this is the sand dunes just south of Lake Athabasca. To see what I showed you, the Carswell, the formation, Lake Athabasca there in the sand dunes, all that is pretty well all sand. And of course the tar sands is part of it. Fascinating geology. So, next crater, where are we here, is Deep Bay. Deep Bay, it's about 9.5 kilometers across. And the dinosaurs have about 34 million years. The clock is clicking. Where Deep Bay is, right about there, though, the inner ocean and the Iapetus is splitting apart for the Atlantic Ocean. So North America is pretty discernible at this point, but we're still getting peppered by impacts. The crater itself, it's kind of a unique one. It's 220 meters deep, the deepest in Manitoba, and essentially all the lakes around are no deeper than 50 meters. So from 50, that's why I call it obviously Deep Bay, 220 meters deep. The First Nations had a superstition about it. They wouldn't fish in there because it was so deep they didn't know what the heck they were going to catch. Yeah, yeah, or big fish.
Is the water clear like in some of the other craters like Pingualan?
Yeah, actually, when we went along the coast, we could see it as clear as Pingualan. I couldn't say. We'd have to be actually right there. No, not even half as clear as Pingualan.
Not clear, but it's cleaner than the other lakes.
Yes. Oh, yeah. We could see we could see rocks along the coast as we went here. And there actually is an outer ring of impact geology that you can see as we flew by it. And I just want to make a note. We're east looking west. We're heading for Fort McMurray way over there. But at this time of this picture, Saskatchewan, if you remember, had some major storms, major thunderstorms and tornadoes. And that there is a storm cloud of those tornadoes. It was severe clear up here where we were to the north, but Saskatchewan was really getting hit. And looking from the west, looking east, you can see there's Ontario, crystal clear skies all the way back. So yeah, we had a lucky trip there that way. So let's see, where are we here? Storm, yeah. And the final one, where are we here? Maple Creek. Now Maple Creek is a small one, 6 kilometers across, 75 million years ago, almost at the point where the dinosaurs met their extinction. Yeah, you would think they'd realize that after 6 impacts, we better do something, but they didn't. That's pretty well where it was, and not much to see, but that's the relative size of the crater itself, 0.0 right there. Essentially, nothing's happening there at all. Nothing, absolutely. So there we go. You see a comet? Well, let's hope it misses us. That's all I can say. I just want to make a plug here. I'm the keeper of the web now, and I know a lot of you have images, and what I'd like to do is put the odd image up every week or every month, depending on how many images I get. So if anybody wants to have their image posted on the front page of our website, please email me. You don't have to send the image to me, just give me a URL where it is. I'll download it myself and then put it on. So there we go. Thank you very much.